in the next couple of minutes, I will show you moments of passion, so why space is so interesting for all of us. I will tell you a short story about space engineers and aliens. Then you will learn some basic facts about astronomy and how astronomers with their telescope use that. And last but not least, you will learn how to start your own space exploration and how easy it is currently to do space exploration. So imagine, it's dark, it's night, and you look up into the sky and you catch up yourself waiting for that little moment. So while a shooting star is passing by, and so you have that little moment and you are sitting there looking up into the sky, and you wish something. You have one dream, one wish, and you share this with your beloved ones. And so that's why I think space is so interesting for all of us. And so that's why this talk is for you. So for me personally, it starts in the 70s. It starts in the 70s with my dad. And my dad, he worked in French Guiana in South America. For the first space agency, ESA, and so on. And he was a leading rocket engineer on the Ariane rocket. And they built on the circuit boards, and they worked on the satellites and on the telescopes. And he told me a little secret about all space engineers, what they had done in their daily lives. So while they're working on the circuit boards with all the electronics, they imprinted their names on the circuit boards. So they wrote down their stories, their family names, the children, stories about their lives. They wrote that down on the rockets, on the satellites, to send them into space. And so my father told me this little secret. Back in the time, he told me, so if someday comes alien to Earth and they ask for my sister or for my brother or for me, then you know why they are searching for you and why they know your name. So because they imprinted it on the boards and sent them to space. So, and that was for me the first touch point, the first beginning of space. And so I went to primary school and then I went to secondary school. And I have to tell you, I have the worst grades you can ever imagine in school. So I finally failed several times in school, and in Germany we call it Hauptschule. And my teachers told me all the time not to study something complicated, not to study, for example, physics or medicine or all that stuff. I should do something simple. And my teacher also told me, Bur, bist total deppert. So. Yeah, so I have to sit down and learn, but it didn't turn out very well. And so it took me a couple of years to come over that point to realize, okay, I have to do something simple. But over that point, above that point, I realized I have to change something, I have to change myself, and start studying and start learning more and more and more. And so after that, I've made my PhD in surgery. I studied micro and nanotechnologies, systems engineering, and finally astrophysics. And that's why I give you now some basic introductions about astronomy, what you need to know if you look up into the sky with a telescope. So if we look up from a telescope on Earth into space, and if we want to look at some galaxies far away, we have to think about all the atmosphere layers. So we have there the troposphere, the stratosphere, mesosphere, thermosphere, exosphere. We have to look through all the layers of the atmosphere. And as you can imagine, atmosphere has turbulences and so distractions. And if we look with our telescope from Earth into the sky, with all the turbulences, the images get blurred, distracted, and they are not so sharp. And so here you can see the difference between an Earth-based telescope and on the other side on a space-based telescope. The Earth-based telescope, it's blurred, it's dizzy, sometimes you have the movements of your of your machines, of your telescope and that stuff. And the space-based telescope, its image is much brighter, much more colorful, and it's like HD, so it's really high definition, high quality. The next thing you need to know is about the spectrum. So if we are watching with our telescope into the sky, we mostly use the visible spectrum, so that's what we are seeing with our eyes. But as you know, as you go to the doctor, you also have other types where you can discover the body and also space. So we have in space, we have the ultraviolet spectrum or the X-ray spectrum or infrared spectrum. So that helps us, as the doctor helps us, for example, the ultrasonic spectrum to look inside the body, or the X-ray to look at our bones. And exactly the same we're using in space, to have different images, different views in space to understand galaxies, planets much better with that different views of the spectrum. The third thing, the problem we have is the light pollution. If we're in Munich or in London or even in Switzerland or in the Alps, there's always light pollution, and that's often a problem if we look up into the sky, so also the images get blurred, distracted with the light pollution. So this we need to avoid more and more to get better pictures. The last thing is we only can make observations at night, and only 35% are cloud-free at night. So this means we only have a short fraction of time where we can do observations in space to use that for making images, for making films. So that limits us totally. So here you can see the difference between earthbound telescopes we have and space-based telescopes in space. And on the one side we have restricted access. The restricted access, that means ESA and NASA, for example, and the Hubble telescope. We altogether could not really use the Hubble telescope, so and also on the ESO and so on, they are totally restricted for observatories, for big business corporations to do the space explorations. On the public side, on the public access, we have some earthbound telescopes where hobby astronomers can more and more easily use that telescopes for their observations. But in space, we do not have anything currently. So in space, that has a much bigger impact to us, because in space, as you now have learned, we have a better resolution, we can observe all astronomical objects, we do not have to wait. So a space-based telescope helps us much better to deeply understand space in general, make better pictures, better understanding and analyzing that data. So that's why we started first with a global Earth telescope network. That means we wrote a tablet application, computer application for your computer, where you can log in, and then you can access to more and more earthbound telescopes for free or for a fraction of a couple of dollars. And then you can observe, for example, Jupiter or Mars, or what kind of star or galaxy you like to observe. You go to that platform and just choose the object you like and take your photos of or images from that Earth-based telescope. With this, we collect tons of photos for more and more analysis or analytics of that, to get a deeper understanding and gain better insights from these images. But finally, at the next stage, we build currently a space telescope for everyone. That means we got currently granted by the European Union, get some funding to build the space telescopes with a lot of Hubble experts and astronauts and a lot of tech experts. To build that space telescope can make better images, and we are able that everyone can use that space telescope. You can just take your tablet or your computer, and then you can remote control this space telescope for a couple of seconds, for a couple of minutes. You buy that slot, for example, for €20, $20, and then you can remote control this space telescope and use this for observation at Jupiter and so on. It's really easy to do the space exploration because you then directly dial in, choose your object and get the photos or more insights and more data, and then you can share this with the crowd, with the community of astronomers. Now I will show you some hidden space treasures. Here, for example, that's the comet Lovejoy that was found early last year from Terry Lovejoy in Australia. That's a colleague there, also hobby astronomer, and he detected that more and more, and insights from that comet, and then it was named after him. So that's also possible for every one of us if we detect some new comets in space. And the interesting thing is there, if we look on the Hubble telescope, for example, is looking in that direction, and the other business telescopes are looking in that direction. But if we gain more and more telescopes, we have more the opportunity to observe like this comet, like the Lovejoy, because we are looking in that direction. The interesting thing also on Lovejoy is that we found there sugar and alcohol, so the first thing of life. So that helps us to get more and more insights how perhaps life begins on Earth. And so we're learning more and more from that. Here, one example, it's the Crab nebulae in the visible spectrum. And if you learned now, also a hidden treasure is because we do not know the Crab nebulae, for example, in the ultraviolet spectrum, to learn more and more from these images what's happening there. So what's also interesting for astronomers, for hobby astronomers, are time series. And here you can see, for example, Jupiter as in time series. And interesting part is to make movies and long time series to understand the fluctuations, the turbulences, what's happening there, the physics behind Jupiter and so on. So this helps us to understand space much, much better. So everyone could be now a real treasure hunter in space, because we have the opportunity to have Earth-based telescope and space-based telescope, for example. And coming to an end, to summarize this, to give you an idea about that, everyone could be a space treasure hunter, and it's really easy to use that. And I would like to invite everyone to write down their names also on the public telescope. And if we send this into space in 2017 or 2018, everyone is invited. And so you can tell your children or your grandchildren also the same story as my father used to tell me 35 years ago. Thank you very much.